Mike.冇無線㗎，唔係有冇嗰種字？因為我要打字。
唔好意思咧，佢用住先，唔好意思。
哦 ，testing。Can you hear me?
So let's start our session.
Excuse me, can you hear me?
Is it okay? Okay. So this section will be given by Mr. Hayden Chung. So his topic will be Memory Forensics 101. So let's give a big hand.
Okay, welcome everyone. Before I start, I would like to ask a question. How many of you are incident responders for your organization or for any organizations? Great. Anyone is a malware researcher? No? Okay, fine. So today my topic is Memory Forensics 101. Of course, the basics. And here we start. So this is today's agenda. We'll talk about who needs memory forensics, why, how, the tools, and the demo. So who? Of course, incident responders, malware researchers, and all of you who are interested in memory forensics. Okay, why we need memory forensics? Because everything happens inside the memory. Everything you do in a computer or anything, smartphone, smart devices, everything happens inside the memory. Every actions you have read-write, it crosses when you need computation, it needs to cross memory. So if you can capture the memory, you can know what's doing inside. Every process, threads, program caches, keys, passwords, clipboard contents, user inputs, screen outputs, network stacks, system configs, more and more, everything happens inside the memory. So even malware has no exception. Malware is usually disk-based, but nowadays we can find more and more malware are evading traditional analyzing techniques. They are using advanced techniques to hide themselves. Advanced malwares usually now has very little trace on disk. Some of it are fully memory operational, which is non-persistence. Every time they execute, they will exploit a flaw. And some of it are script-based, which is very hard to detect, and very light footprint of a loader or dropper. So we need some tools to help us to look inside the memory. We need to analyze what's going on inside the memory. We need to analyze what's the user behavior or the malware behavior, and to grab the information from the memory dump. So when we analyze it, maybe we can attribute the threat actor. Okay, how to do it? Of course, you need to get the memory dump. So by acquisition of the memory dump, and then obviously analyzing it using tools. So if you want to get a memory dump, there are a few ways to do it. Of course, for different operating systems, there are different ways. So the first way for Windows is a very built-in way and a very easy way to do it. When you flip the registry key to crash, dump, enable, and crash on control, swirl, dump, and then restart the machine, and then you press control, swirl up, and swirl up 2 times, then you get a blue screen. Then, yes, basically a blue screen. And then you dump the memory into disk, so you can capture it. And another way to do it is a quite easy way to get FireEye Redline, which is a free tool provided by FireEye. Before it's called Mandiant, which is the company who disclosed APT1. And very easy, just by mouse clicks, there's a button called Collect Data, and then click Create a Standard Collector. Then check the checkbox of Acquire Memory Image, and then you're good to go. They will have a memory dump file generated to your destination where you selected. Okay, for Linux, it's a little bit tricky. You need to have a kernel mode. So you need to get a kernel mode compiled, and then you need to load the kernel mode, which is the following this command. And the tool is called line. So for Mac and Linux also, another tool is called recall. It's also something like kernel mode, so you need to load the kernel. You need to load the kernel mode and then use the command to dump out the file. Of course, if you are doing it in a virtualization environment in a VM, you just do a snapshot of your hypervisor, and then you can get the memory dump file. This is a very easy way to do it. But if you are analyzing some malware which has the technique to evade VM, then you need to do it in the hard way. Okay, so some memory forensics tools we have used in the past. We have already a 3rd generation of tools. For the most basic ones, before memory forensics is a discussable topic, we just simply use basic Linux tools like strings and grips. Because especially for those who are coming from the police, the law enforcement side, they usually don't do memory forensics. They usually do offline forensics. They forensic the disk. So usually their practice is pull the puck and then get the disk, and then make sure the disk is not tampered and image it, and then using some forensics tools, those proprietary ones, and then they get those evidence and present it to the court. So this is less useful to those who are in law enforcement, because memory forensics is a quite fast evolution technique, and it's questionable, is it a court evidence? Because it's very difficult to ensure that your memory is not tampered. in the time when in any time you are acquiring it. So it's more likely useful for malware analysis and incident responders. And the first generation of those tools, which comes from memget, mempeak, LifeKD, and the second generation is Memorize, Windows Memory Toolkit, Volatility, which we'll talk about later, and Recall. And the third generation, we have LifeCloud KD and FireEye Redline. Okay, so today's main topic, I would like to talk about volatility. Why volatility? Because volatility is the de facto memory forensics tool. It is open source. It's written in Python. It's extendable. You can write your own plugins. And a lot of memory forensics users will prefer volatility because it's highly available. You don't need to buy a license for any sorts of other tools. Okay, so how do you get it? Just simply Google for volatility framework. Don't forget the word framework, otherwise you'll get a bunch of other things for finance. Okay, you know what I mean. And then get it in GitHub. Also check the volatility profile, we'll talk about later if we have time, and the guide for building the profile for Linux. Okay, so another thing before I start the demo, just some tips. If you run volatility, make sure you run it in a fast storage, an SSD, or if you have some crazy fancy stuff like Optane, or even you have large memory, you can run it in RAM disk. Why? Because nowadays systems most likely have a few gigs of RAM at least. So if you want to crawl for the memory, if you do it in a slow disk, it will take quite a bit of time. So, oops. Oh yeah, so demo time. Okay, so the first thing, yeah, if you get it from GitHub, of course, you do a git clone, and then the address, and then you get the volatility framework, which not in this directory. Yep, it looks like this. So nothing special right now. Okay, so after you acquired this image, I currently use virtualization technology, so I just have a snapshot and I get the memory dump. So it's fast and easy way. If you need to do it the hard way, yeah, we have discussed previously. And then the first thing you do is help. The help lists all the commands available in your current in your current profile. If you want to have extended features that you load the plugin, you need to have a profile which is matched to your your memory image. So the first thing to do is to have the first thing to do is to identify the profile. So if you want to identify a profile, you would type your command, which is volatility, and then -f is for which file, and then the memory file, and then image info. I won't do this for demo because it will take quite a long time. So when you hit enter, you get the image info, but it looks like this. I'm cheating, yes, because this takes quite a long time. And then it will suggest you a profile. Of course, I know what system it is, so I'm cheating. I know it's a Windows 7 SP1 x64, so I get it, and then I just type it in dash dash profile equals Win7 SP1 x64. Then, first thing I would usually like to do is to know what process is running inside the memory. So a very easy one, PS list, which goes through what's currently running. Yeah, you can see a lot of process. And some are exited, which has a dash here. Sometimes it's exited in some time. And these are all the currently running processes. These are the address of the memory. This is the PID, which is the process ID. This one, the first line number. And the second line number is the parent process ID, which is the one who calls first, which program calls the memory, which program calls the child. And then, if you want to have a look in if you want to look in the hierarchy of what's running, so we'll use PS3. PS3 will have a similar view of what's going on in the hierarchy level. So if you are familiar with something in Windows like Process Explorer or that kind of tools, you will know that. Yeah, this is the tree. So you can see which process is running, which process spawns by which process. Okay, and then the next one is PSXView. PSXView is a quite interesting command which gives you an idea of is there some process which is spawned by another process and it quits. So you can see some abnormality here if you use this command. And then another one is command line, CMD line. CMD line, which, as its name, you can see the full command which it is running. So if it is SVC host, then you can see what's going on. Then another one, usually when we analyze a machine, sometimes the shutdown time is useful for us because we would know what time the machine has have done a reboot or a shutdown. So we can guess the behavior of the system. So shutdown time is another command. These commands are sometimes quite slow. I'm already running it on an SSD. So here we get the last shutdown time. And then, as I've said, when we look through the memory, you can also see through memory stacks, network stacks. And the next one is NetScan. NetScan works on Windows 7 and Windows 2008 server. And there are some equivalents in Windows XP memories. So let's do it. So we have all the process which are using network. We have what protocol is it? The local address, the foreign address, the state, and what time it's created. You can see we have something listening. A bunch of listening ports. And then, we have some abnormality here. Does anyone knows that the spooler would connect outside? Yeah? Anyone? Is this an anomaly? Yeah, I guess so. Okay? Okay, so if you are working with Windows XP, the equivalent command of it is connections. Oops. Yes, connections. Connections is the equivalent command which lists all the connections, and then there is another one, socket. Sockets, which lists all the listening sockets. And then we have sockscan, which lists more details inside the socket's connection. Okay, so, whoa. So after viewing about the memory, the network stack, we would like to have something to look at the DLLs which are used by the process. So I'll just get back the process list and let's see what's interesting here. Okay, say, I want to know what this is. This security boot. So I have the process ID of 1608. I'll use the command DLL list, and then -p for the process ID, and then the process ID 1608. So if you look through what's loaded in the DLLs, you can have some idea of even what programming language this program is written. Say here, you see that it's written in Visual Basic 6. Okay, so another very useful command is called malfind. Malfind is the command which finds out the anomalies that are written in the page or the stack of the memory. So malfind identifies those activities. You can see everything it most likely identifies as a page execute write. Does anyone know why this is a malicious activity? Anyone? Yes, because usually programs write once and read the memory for its use. Usually it doesn't rewrite something. If it rewrites something else, that means it's trying to grab memory and then trying to alternate it. So this is some fishy action. So, and here, inside those hacks, sometimes we'll find, yes, something starts with MZ. Something starts with MZ is very wrong. MZ is the start of a portable execution, which is exe or DLL. Something executable inside another executable. That means that process is being injected. Okay, and then the next command is process dump. If you want to get, if you have a memory dump of the system and you want to get what's loading inside, you can use process dump to get the process extracted out of the memory. So let's use proc dump, and then the process ID, say, what's the before, 168, yeah. And then we need to give the dump directory. So dump dir, I'll just dump it here. And then we'll have the dumped out executable here. And then you can analyze it with any other tools. Say if you want to have strings. This W string thing is wine executable, which is sysinternal's equivalent string. Which one? Yeah, this one. Yeah, and then you'll get out all the strings of the executable. And then another one is hash dump, which is useful for identifying the system's user accounts or what user is currently interacting with the system. If we use hash dump. Yeah, make it type. Takes a while. Yeah, here you see there's the NTLM hash and then the username. And then, of course, clipboards. This is also a very interesting information that you can get out with your memory dump. Again, this takes a while. So what you have copied and pasted would be found out inside the memory dump here. Yeah, something like this. Okay. The next one would be Windows. What Windows you would say? Okay. This is listed out all those Windows overlays inside the current state of the memory, which means this is going to be slow. Yeah, a very long list, which means every Windows draw on the screen, it has the location and it has the state. So it's quite useful if you want to see is something hidden inside those different layers. Say something running but it's not displayed on screen. Okay, another one, of course, if you wanted Windows, then you would love a screenshot. Okay, a screenshot, and then, yeah, I need a dump directory again. So this one would be, oops, oh, I can't type. Yeah, so like that. You can get out all those windows which are drawn on the screen, and then you get an image file. Okay, another one is, okay, the next one is I'm going to show something not just Windows. Actually, how you could use it in Linux environment. Because this is a bit tricky, you need to load a profile. So when you start your Yes, here is the build instruction for Linux. Because if you need to analyze the Linux memory, you need to have a profile pre-built for volatility, which is different for each system, each kernel. So you need to get it built for your system. And here's the guide. It's very easy, just going through it step by step, you can get your profile. But because this way, you need to get a profile for your specific target system, so I don't think it is a very good idea for, say, if you are law enforcement, that you need to do something that is not tampered with the system. Okay, after you get your profile, where would you put it? You'll put it inside volatility, and then plugins, overlays, and then Linux. Okay, so here you can see I have my profile here written in this directory. So after you have this profile, you could specify your profile to your plugin, and then you could use volatility for its work. So the first thing, same as Windows, so everything in Linux, the command starts with Linux, and then underscore, and then get out order process, ps list. And then you have what's running currently inside your Linux box, all the kernel starting things. Then, same as Windows, ps3, the hierarchy of the running process. Another one is psxview, another same equivalent as Windows, and then another one is psaux, which is listing out all the commands with the arguments. This is very useful for Linux box because everything doing inside Linux is usually has a complete command, and this lists out the complete command of it. And then we can see also the environment, use ps environment, psenv. This lists out all the environments of each identified process. And then we have kernel modules, ls mode. So we can see what kernel module is loaded inside your Linux box. You can use ls mode. Another command for network stack, ifconfig. Very simple. And then, same as Windows, you have netscan. Takes a while. Yes. Okay, so after netscan, we have netstat, which is also very familiar of you guys if you're running Linux. Another one is uptable. You can see what's interacting with the local network. So something very similar to Windows, you can use Marfine. Which is the equivalent of the Windows one. Okay, so these are the demos. So, any question?
So if there are no other questions, so let's give a big applause to the speaker.
Okay. Thank you very much.
We'll have a short break, and the next session will start at 4:20. Okay. Thank you.
I have a question.
Hi.
That I used to analyze some Linux kernel column before, and at that time I used a mechanism called KDump.
KDump, yes.
Yeah. So